Can you hear me? Yeah, I can hear myself. So, hello, my name is Razvan. I think we've already met. And I'm here to brag about the new cluster module that we've just developed. I'll keep this presentation short because, they took a little bit of my time, with my permission, of course. So, we'll be talking about sharing data in OpenSIPS. In OpenSIPS 1 dot whatever, and OpenSIPS 2.2, the new OpenSIPS we've just released. Let's see, what are multiple nodes? It's basically multiple nodes that do the same thing, have the same configuration, but we keep them on separate servers, and because ideally they should be in different locations. Why would we use that? In order to increase capacity, to do load balancing, for failover and high availability stuff. I bet you all know why we would use multiple nodes in order to scale. There are different schemes that can be used. One of probably the most popular is active-active, where we have multiple clients trying to reach a bunch of nodes. They don't really know where to go, so we have to have some sort of load balancer. Even this can be a DNS balancer, or why not an SBC, a C balancer over here, which dispatches data to these nodes. However, we can do it in two different ways, like stateful and stateless. Stateful means that if a client starts a call through node A, all the messages should go through node A. So there has to be some sort of mapping here. Well, we can do it at level 2, or in the stateless way. So this means that if client A1 starts a call through node A, it can finish it through node D, for example. In order to be able to do that, we need to share, in this case, the dialog data. Moving on, another very popular scheme to use is active backup, where we have a node, a master node, which handles all the traffic. However, we also have a backup node that has to be a hot backup, has to somehow know all the information. Why? Because if somehow something happens and node A goes down, it has to become the primary node. It has to be the one that handles the traffic. And in order to handle the traffic, it must know all the dialogues, so somebody must have told him that. So again, A prime must know all A's data, so we really need to share this information. How can we do that in a centralized or decentralized way? If we use the centralized way, having, for example, one database where everybody writes and reads, can be done. However, first of all, this doesn't scale at all. And the data is stored in a single central place, so we have a single point of failure, and it's very hard to manage stale data. For example, if one node goes down, somebody has to know that and erase the information that the management is very hard. In a decentralized way, the data is stored on each node, and node replicate data to each other, and each node has its own copy of the data. The stale problem is solved when, for example, if you detect a node is down, then you can delete everything about it. But we'll discuss about this a bit later. Let's see how this can be done in OpenSIPS. So we have MySQL. You could use the MySQL replication stuff. You could use stuff like Percona, Galera. You can use PostgreSQL. I've never used it, but I heard very, very nice stories about it. You can also use NoSQL engine to share data between different nodes. We have drivers for Cassandra, Couchbase, Memcache, MongoDB, Redis. So you can use this. However, I find the problem I find with this is that each of them are servers, so you have to maintain another service, one or more services on your platform. That's why in 2.1, if I remember correctly, we introduced the bin interface, the binary interface. It's an interface that OpenSIPS uses to replicate data intrinsics. So OpenSIPS itself replicates data to all its other nodes. It does it first did it using UDP. It's a very efficient protocol. It's very compact. It's a binary protocol, so only sends the information that really needs that the other nodes really need. And also can aggregate information. So instead of sending 5 registers, it sends a single message with information from 5 different registers. Yeah.
Would it be full mesh in this case? If that
yes.
Makes sense?
Yes, it's full mesh. We'll discuss about this a bit later. However, the problem with this is that it's based on UDP, and UDP does, first of all, does not guarantee the order of the messages, nor that the messages are actually delivered. So we somehow had to treat the problem of losing messages or message ordering, and we had to do something like to implement a protocol where with sequence numbers and a lot of headaches, something that TCP already solved, right, during the years. That's why in 2.2 we have a new bin interface that's built on top of TCP, which solves all the UDP issues, the ordering and the message loss problem. It's more efficient because it's built on top of the transport interface. So basically uses the same TCP stack that OpenSIPS uses for TCP and TLS. So it's very, very efficient, it's very fast. And it's very easy to use programmatically because that's the only way you could use it until now. Basically the modules have to replicate data to themselves, so the nodes know exactly what to send to the other nodes. Who uses it? In 2.2, for example, ratelimit uses it to limit the calls per second, dialog, and user location. Let's see. Ratelimit can be used to limit the calls per second the entire platform can do. Because basically the problem is that if one customer starts to make some calls, and you have set a limit of X to that customer, if he reaches node A with X calls per second and node B with X calls per second over the platform, the rate is like 2X's, which is not correct, right? So basically these two nodes should share this rate limit context. Again, dialogues can be shared in order to offer high availability, something we discussed earlier. So in case one node goes down, the other node can handle the same dialogue. You can also share dialogue profiles. Dialogue profiles are used to group dialogues based on, I don't know, certain profiles like incoming, outgoing. This way you can limit the outgoing dialogues or the outgoing calls or PSTN calls. They are very useful, and can also use the user location. Can share user location. For example, if this client registers to node A and node B wants to reach it, node B has no idea where client 1 is. So node A can share the user location information to node B. This way, node B, even though the client registers to a single server, node B also knows his location. But if there's not, that won't work. So actually, even though if there was not, this information is useful because, for example, you still have to share some information. In this case, everybody needs to know that node A knows where client 1 is. So everybody needs to know that. So in case node B wants to discuss with client 1, he must somehow know that he should go through node A. So yeah, well, in 2 steps because that's what NOT does. But still is something that you want to share. Okay, so we have nodes, but we somehow have to provision. We somehow have to tell them who talks to who, right? How this node knows about this node and this node and this node, where to replicate this data. And we try to think how we would provision this and how this would work. And we thought of clusters. Basically what a cluster is a group of nodes or instances with the same function that need to communicate between them. So inside the cluster there has to be a full mesh, but they somehow need to know each other. Somebody has to tell them, you talk to node A, you talk to node B, C, and D, and the other way around. Provisioning this in configuration files would be easier if you could use, for example, a shared file system and you only modify one file, but it's even easier if you're doing it in database. So we put together the clusterer module, which is basically an interface used to group multiple nodes in clusters. Basically, a node is defined by a connector. Currently, only Bing connectors are supported. That's because all the nodes that replicate data over the Bing interface. But however, we could, for example, group MI connectors, for example, MI XML RPC connectors. And if you want to trigger a command on the entire platform, all you have to do is send it to one node, and everybody will reload, for example, its cache. Groups and clusters can have different purposes. For example, sharing 2 nodes can share dialog information. Other 2 nodes can share ratelimit information. One node can share with a different node, I don't know, dialog profiles and so on. So a node can also be part of multiple clusters, so you can group them whatever you want. Everything, as I said earlier, everything is provisioned in database, and nodes are cached in OpenSIPS memory. So basically, you can query OpenSIPS using the MI interface to see what connections are up, what connections are down. It also does timeout management, and it's very granular. You can specify a node how fast it can reach a different node, and so on. You can also specify the data flow, which node can broadcast data, which node can accept data, which node who to trust, and stuff like that. So it's very granular. Each node communicates with all nodes, so it's as I said earlier, it's a full mesh. Each node has all the information of the cluster, so it knows all the paths to all the other nodes. If a node does not respond for a specific duration, there's a timeout. We had a few discussions about how to handle this case, what to do with the information that we got until then from that node, because we can simply erase it and basically invalidate all the data that was gathered from that node, or we can keep it for a while in a, let's say, it's proving or stale state, and if the node doesn't come up in a reasonable amount of time, that's configurable, so all of these are configurable, then discard the data. This is very useful to mitigate the stale problem I said earlier, because, for example, if let's say a customer is flooding one of your node, and the node goes down, all the other nodes will think that the customer is still flooding, even though he stopped. So it's very important to erase this data, to recover from this state. Okay, how to provision this is very, very easy. I'll show you a few slides. I told you I don't have that much to show. So we will be using the new control panel tool where we can provision nodes. As you can see, all you have to do is provision a cluster ID, a server, the URL, basically the connector that's used to replicate data, and, well, a description. Okay, so let's see. I'll do a register right now. Let's see. Okay, so I registered a CPP instance. I'll run on node 1. Nope. Something else. So node 1 now has this location information. In this case, we don't have the net, so we believe that all nodes can reach that user, because it's true, actually, it's the same machine. But anyway, node 2, again. So as you can see, from probably not sure how many of you are familiar with the control panel, but the idea is we have two connections, and this is node 1, this is node 2. They both share the same information, even though I only registered on one server. There's another node provision here. If I run a dump, he also has this information. That's because I didn't flush earlier. Okay. Sorry about that. Okay. Here we have a user agent server. I will start some 10,000 calls. Okay. Let's see the rate limit. So node 3 doesn't have any information about this pipe down, right? Node 2, no. Let's see. Node 1. It's not. Oh, I know what's happening. Yeah. So the rate is 30 calls per second. That's what the counter, and the limit is 100. We only deliver calls to a single node, but node 2 also knows this. Has the same counter, 30. However, node 3 doesn't even have this this limit. Why? Because as we've seen earlier, node 3 is not part of the cluster. So we have to add it. To add it, we simply add a new cluster. We use the same cluster ID because all the nodes are part of cluster ID 1. We need to have a different server ID. 70. That's the URL, and that's node 3. Okay? Is he part of the cluster now? Not yet. Because, well, node 1 doesn't know anything about node 3. Why? Because we didn't hit reload. So we always have to apply changes to the server. Now it's part of the cluster. And if we go to the... Okay, created the... I don't think there are any calls now? No. Okay. Now we should see the same counter on the third, on node 3. So now it's part of the cluster. It was that simple. In terms of configuration, you'll see that's, again, trivial. I'll show you a configuration script over here. Let's see where it is. There it is. Okay. So the first thing to do is to add the bin listener. This is the way you add a bin binary listener, binary interface listener. Next, all you have to do is instruct user location, the user location, and it can also accept the replications from cluster ID 1. Okay? As I said, this is very granular. You could, for example, replicate context to somebody else, but somebody and receive from somebody else. Again, you'll have to load the proto-bin module because this is the way the replication is done. For the cluster module, all you have to do is specify the database to use and a server ID. Basically, you have to tell him which of the three servers is this instance. Okay?
Don't have to load the TCP is loaded on by the proto-bin?
Yeah. Yeah. Actually, no. You don't really. You ask if you need to load the TCP module.
Because it runs on TCP, but it's still, but it has its own.
No, it's not necessary. So if bin is used, then the whole TCP interface is loaded. If not, it is not. Okay. Again, for ratelimit, all you have to do is to instruct it to accept pipes from cluster 1, and if a pipe doesn't, if you don't get any information within 5 seconds, then put that node in a probing state. Similar to the configuration of the dialog module. You can replicate profiles to node 1 and dialogs to cluster 1, and accept replicated profiles from cluster ID 1. And that's it. That's all you have to do. Provision the nodes in database and instruct each node its server ID and whom to accept data from and where to send it. That's more or less it. For the future, we have some very nice plans. There's actually some ongoing work for the cluster module to dynamically learn the network topology. So in the future, you simply power up an instance, and everybody knows about it. They will be able to communicate through alternative routes, so it won't always be a full mesh. We can have a different topology with weights on each communication links in order to find the fastest route through nodes. So to make this very, very efficient. So we are working on this as we speak. There are some guys back home that are doing this right now. We found an algorithm to distribute user location data to different nodes. So for example, if you have a huge amount of user location data, we split it in multiple parts, and each node knows something about some nodes. So this is similar to the chord algorithm, if you are familiar with that. And for the future, we would like to add replication support for different other modules, as well as distribute dialogues, because this is a lot of information that has to be stored. And if you have like 100 nodes and you're doing like 10,000 dialogues, let's say, it's a huge amount of memory that you use. So you somehow want to distribute this memory usage on several nodes. Thank you very much for your attention. If you have any doubts that you can use OpenSIPS to share data and do it in a very scalable and distributed way, you'll have to argue with me. Otherwise, just use OpenSIPS 2.2. Thank you very much. If there are
What happens if you've got like two nodes in the mesh can't talk to each other, but they're still up and running? Do they both time out, or?
Currently, yes, but this.
That will get around that.
This, yeah, will help them find a different route for them to be able to talk. Go ahead, then.
Is the replication model transactional? And if yes, how does it impact the latency?
No.
What happens to the race conditions?
They are solved at the application level, let's say. So it's not. They are not. The answer is no. They're not yet that smart. Okay?
So if each node has a different IP address,
Can have the same IP.
okay. So would they normally have the same IP? If they have a different IP and say a dialog was okay to go.
Oh yeah. So
how would OpenSIPS?
you are talking about sharing dialogues that can be somehow that are bound to one specific interface, right?
Yeah, or nice.
So because if you receive a dialog on a interface, you have to respond. The answer is actually my hack here on my setup was to put all the instances to listen on that single IP and use that IP non-local bind, something like that, system control setting in Linux, which allows you to bind on an IP that's not yours. And use something like Heartbeat or VRP to move the IP whenever something goes down. So that's the solution now. I think there are other solutions, but I'm not sure how those will work. Because you probably know, usually you have NAT and you will also have to use that specific IP to respond to customers. So I think that's the easiest way to go for now.
So there still needs to be a plan in place to say this IP is down, the traffic needs to shift, or the IP needs to move to one of the other.
True, somebody has to take this decision. Yeah. If you're doing the active-active scheme, then well, you still have to coordinate between all those instances to only one take active, to only one to respond to whatever event.
For active standby, it will work.
Yeah, it will work like that.
When the node goes down, it comes back up as a capital. The record node makes it lost when it goes down.
So if a node goes down and then comes up,
will we get all the information from the other server? Or
yes, it will get all the information, all the new information, not the old one. Because basically, the way it's done now, everything.
By the time it was down, 10 minutes, that information is gone?
No, it's not that, because the other two nodes, let's say, have it, and will send it to yes. Basically, the way it works now, so there are two different. This I think answers also your question. There are two modes. Some modules replicate a snapshot, so they simply send, this is my state now, this is all I have now, this is all I have now. And some nodes do updates like, okay, this contact is now on, this contact is deleted.
That will be lost.
Yes, that will be lost, but usually when you have this kind of, let's say, very unstable environment, not really unstable, let's say very dynamic, you probably want to, for example, set a small amount for the registrations to be valid, like 60 seconds or something like that. So this somehow can be solved on the application level, not on the protocol, because the protocol itself is quite simple. All it has to do is replicate data. Doesn't really know what, I mean, the cluster itself being so generic, simply replicate data and that's it. That's all it knows.
They don't sync to replicate.
What?
They don't sync each other, they just replicate.
They don't sync.
So if one is down, you lose information.
Yeah. So, well, that's why you have a full mesh for everybody. Okay, thank you very much. Then now I think, okay, Alex, go. Right?
You got one job, man.
Yeah, thanks.
Thank you,
Thank you.
Razvan. We're going to break until 3:30 here for some tea and coffee, and we should be refreshed in there. So everybody back in about 25 minutes.